This is for the online lab on concentrations. So I'm going to follow my instructions and I'm going to load the homework here in Iridium. That says molarity and density, dilution problem 1. Okay. Then my instructions are, on your workbench, assemble the following glassware and stock solutions. So 1 molarity glucose Erlenmeyer flask, and that's this one here, that's an Erlenmeyer flask. 100 milliliter volumetric flask, and there it is, and the distilled water container, there it is. Okay. Then it says pour 2.5 milliliters of the 1M glucose from the Erlenmeyer flask into the volumetric flask. So 2.5 pour, there it is, and then use the dilution. Use the dilution equation to determine the volume in milliliters for the required 0.025 m solution, given that the original solution is 1 m and you used 2.5 milliliters. Fill the volumetric flask to the 100 milliliter mark with distilled water. Note, the flask already contains a volume of 2.5 milliliters. How much distilled water do you need to add to get a total volume of 100 milliliters? And I'll let you figure that out from here on. What I'm going to do is actually an example, but I'm going to use different numbers. Here we go. Let me get rid of these here, and as I said, I'm going to use different numbers. There we go. So I pull this one over here, and I'm going to get this one here, and there we go. And the different numbers I'm going to use is I'm going to use 8 milliliters rather than the 2.5. I don't want to take work away from you, so I'm just going to give you an example here. My example is with 8 milliliters. You do the one that is required of you in the lab sheet. So I need to fill it up to 100 milliliters, so I pour in 92 milliliters because it already contains 8 milliliters, and of course when I click on this one here it says 100 milliliters. Okay, so here I'm going to work on that and on the lab sheet and write down the dilution equation. That's what I need. And in the book, for example, I can go to the index, look under dilution, and it says, hey, equation that is giving me the dilution calculation, and I find that in the book, and it says that the concentration of the stock solution times the volume of the stock solution equals the concentration of the diluted solution times the volume of the diluted volume. Now, when I calculate this one here, then I say, okay, my original concentration was 1m. My original volume that I used was 8 milliliters. Remember, these are my numbers, not yours. My example. And then what I'm supposed to come up with, well, let's see what I come up with in a moment. So I'll write down CD here again. And then, times, and then the volume of the diluted solution, well, it's 100 milliliters, and when I multiply that out, 1 times 8 divided by 100, I come up with that CD equals 0.08 molarity, and we can see that on the side here, it's still in the screen, that this one is a 0.08, and of course over here, as I said, I changed my numbers, compute the volume of the diluted 0.08 m solution. And again, in my example, I personally am changing some of the numbers here. I just keep repeating myself. This is an example. Your numbers are going to look different because you're going to do the real lab report, but I don't want to take too much work from you. So, is 8, I let you answer that. What volume of solute did you use to prepare the 0.08 molarity glucose solution? Well, I used 8 milliliters. And then, is distilled water your solute or a solvent? I'll let you answer that. What volume of solvent did you use to prepare the 0.08 m glucose solution? Well, I used 92 milliliters of water to make it for a total of 100 milliliters. What is the volume of the solution we prepared? Well, that's a total of 100 milliliters. Write down the molarity equation. One way of doing that is look in the index on the molarity, and it says equation to calculate the molarity. So I looked that up, and it is that molarity equals the number of moles divided by the volume. And then here here again my example, since I used 8.0 milliliters of one was used, compute the number of moles of glucose present using the molarity equation. Well, so it says here, since 8 was used, compute the number of moles of glucose present in the molarity equation. So I'm going to do, originally was 1m, and that equals the number of moles, divide by the volume of 8.0 milliliters, because that's what I put in. However, that volume has to be in liters of solution, so I have to convert that. 8.0 milliliters comes out to 0.008 liters, and so I multiply 1m times 0.008 liters, and therefore I'm going to come out with 0.008 moles. And now I'm going to do the same thing for the diluted solution, where I ended up with a molarity of 0.08, and that equals number of moles, divide by the total volume of the solution, which was 100 milliliters. But again, I have to convert that to liters, so that's 0.1 liters. And now it's going to be 0.08 m times 0.1 liters, and that comes out to 0.008 moles. And now you can answer this question here as well, and again I'll let you do it. And remember, these are my example numbers. These are not yours. You have to use the 2.5 milliliters of the original solution that you have to use.